In this module, we shall cover standards and protocols and their need and importance in digital libraries. We will also gain knowledge on interoperability and data exchange in digital libraries and roles of standards and protocols. We will also learn important standards and protocols applicable for digital libraries. It is a fact that building a digital library requires a number of infrastructural software and hardware components. There are no turnkey monolithic systems available for digital libraries. Digital libraries are collections of disparate systems and resources connected through a network and made interoperable. To have seamless integration of various components for its efficient functioning. Standards and protocols have a major role to play in building a digital library. Uniform standards and protocols are a prerequisite for data transfer, exchange, and interoperability amongst digital libraries. Let's have a look at the definition of protocols and standards. A protocol is a series of prescribed steps to be taken, usually in order to allow for the coordinated action of multiple parties. In the world of computers, protocols are used to allow different computers and software applications to work and communicate with one another. Computer protocols are frequently formalized by national and international standard organizations such as ISO and ITU. A protocol that is accepted by most of the parties that implement it can be considered as a standard. However, every protocol is not a standard, and similarly, every standard is not a protocol. Standards support cooperative relationships among multiple vendors and implementers. Standards also make it possible to share and collaborate in development of products and processes across institutional and political boundaries. Standards are supported by a range of national and international organizations, including professional associations such as the Institute of Electrical and Electronics Engineers, the American National Standards Institute, the British Standards Institution, the Bureau of Indian Standards, International Organization for Standardization, and the US National Information Standards Organization. For promotion of standards relevant to digital libraries, a number of important institutions and organizations are actively involved. For example, Digital Library Federation, a consortium of libraries and related agencies, as one of its objectives, identifies standards for digital collections and network access. The DLF operates under the administrative umbrella of the Council of Library and Information Resources located in Washington, D.C. The Library of Congress plays an important role in maintaining several key standards such as MARC and the development of MARC with an XML environment. The International Federation of Library Associations and Institutions, IFLA, maintains a gateway, Inflanet Digital Libraries, to resources about a variety of relevant standards. Now, let us discuss communication protocols. Communication protocols are predefined sets of prompts and responses which two computers follow while communicating with each other. Digital libraries are designed around the internet and web technologies. Communication protocols such as Transmission Control Protocol or Internet Protocol, Hypertext Transfer Protocol, HTTP, and File Transfer Protocol (FTP) are also used for establishing communication between the clients and servers in a digital library. We have already studied that the Internet is a packet-switched network wherein information to be communicated is broken down into small packets. These packets are sent individually using several different routes at the same time and then reassembled at the receiving end. Transmission Control Protocol is the component that collects and reassembles the packets of data. Internet Protocol is responsible for assuring that the packets are sent to the right destination. TCP and IP was developed in the 1970s and adopted as a protocol standard for ARPANET, the predecessor to the Internet, in 1983. The pictorial depiction of TCP and IP model is as shown on your screen. TCP/IP is the protocol that controls the creation of transmission paths between computers on a single network as well as between different networks. TCP/IP defines how electronic devices like computers should be connected to the Internet and how data should be transmitted between them. This protocol is used universally for public networks and many in-house local area networks. The Hypertext Transfer Protocol, or HTTP, is used by the World Wide Web to define how messages are formatted and transmitted. It needs an HTTP client program or an internet browser on one end and an HTTP server program on the other end. The HTTP protocol is used for carrying requests from clients to the server and returning pages to the clients. It is also used for sending requests from one server to another. HTTP is the most important protocol run on top of TCP/IP used in the World Wide Web. HTTP was originally proposed in 1989 by Tim Berners-Lee, the co-author of the 1.0 specification of HTTP. As per the displayed schematic on your screen, web browsers are HTTP clients that send file requests to web servers, which in turn handle the requests via an HTTP service. The File Transfer Protocol, or FTP, is a protocol for transferring files from one computer to another over a local area network or a wide area network such as the Internet. It is a common method of moving files between clients and servers over TCP/IP network. The protocol is in existence since 1971 when the file transfer system was first implemented between MIT machines. FTP provides for reliable and swift exchange of files with different operating system and machine architecture. The graphical representation displayed on your screen describes the working of FTP. There are many internet sites that have established publicly accessible repositories of material that can be obtained using FTP by logging in using the account name Anonymous. Thus, these sites are called anonymous FTP servers. So far, we have covered communication protocol and standards. Now, let us discuss about bibliographic standards which are applicable to digital libraries. Bibliographic standards are concerned with the description of contents as well as physical attributes of documents and non-documents in a library. They are generally very complex. MARC has some 700 field definitions, and they cover the most difficult and intellectual part of the object definition. These definitions are necessary for processing the material and also for searching it. Most digital libraries software support Dublin Core metadata sets for bibliographic records. MARC or Machine Readable Cataloging Standards are a set of formats for description of documents cataloged by libraries, including books, journals, conference proceedings, CD-ROMs, etc. Machine readable essentially means that a computer can read and interpret the data given in the cataloging record. Historically speaking, MARC was developed in 1960s by the US Library of Congress to create records that can be used by computers and shared among libraries. MARC contains bibliographic elements for content, physical, and process description. There are several versions of MARC in use around the world, the most predominant being MARC 21, created in 1999 as a result of the harmonization of US and Canadian MARC formats and UniMARC widely used in Europe. The MARC 21 family of standards now includes formats for authority records, holdings records, classification schedules, and community information, in addition to the format for bibliographic records. On the other side, the Dublin Core refers to a set of metadata elements that may be assigned to web pages so as to facilitate discovery of electronic resources. The DC was originally conceived for author-generated description of web resources at the OCLC NCSA Metadata Workshop held at Dublin, Ohio in 1995. DC has attracted the attention of formal resource description communities such as museums, libraries, government agencies, and commercial organizations. The central feature of Dublin Core is the building of an interdisciplinary, international consensus around a core element set. A set of 15 core elements in Dublin Core include title, creator, subjects and keywords, description, publisher, contributor, date, resource type, format, resource identifier, source, language, relation, coverage, and rights management. BIB1 is a simplified record structure for online transmission. It is essentially a subset of MARC. It is the original format for transmission of records within a Z39.50 dialog between two systems. It has elements that are mappable to both MARC and the Dublin Core. Text Encoding Initiative (TEI) provides a scheme for encoded text so that parts of it, such as the start and end of lines, paragraph, pages, chapters, acts, and so on, can be marked to enable such further processing to produce accurate indexes for searching. Other features of the text, both grammatical and linguistic, and also content indicating, such as the actors in a play, can be identified, allowing for a rich analysis. These rules require that the actual text be marked up with SGML encoding. The electronic archival description is an encoding scheme devised within the SGML framework to define the content description of documents and other archival objects. It is defined with the minimum number of descriptive elements, but in an extensible fashion. EAD is designed to create descriptive records which will assist in searching for the original material in a number of ways. Metadata Encoding and Transmission Standard, or METS, has the task of encoding descriptive, administrative, and structural metadata for objects in a digital library to facilitate the management of such documents within a repository and their exchange between repositories. METS is maintained by the Network Development and MARC Standards Office of the Library of Congress and is an initiative of the Digital Library Federation. The METS format has 7 major sections as shown. The descriptive metadata section points to descriptive metadata external to the METS document or contains internally embedded descriptive metadata or both. The administrative metadata section provides information about how the files were created and stored, intellectual property rights, the original source from which the digital library object document derives, and information regarding the provenance of the files comprising the digital library object, that is, a master or derivative file relationships and migration and transformation information. As with descriptive metadata, the file section lists all the files containing content that form a part of the digital document. The structural map provides a hierarchical structure for the digital library document or object and links the elements of that structure to content files and metadata that pertain to each element. The structural links section of METS allows METS creators to record the existence of hyperlinks between nodes in the hierarchy outlined in the structural map. This is of particular value when using METS to archive websites. The behavior section associates executable behaviors with content in the document. The metadata object description scheme was developed as a descriptive metadata scheme oriented towards digital objects and drawing from the machine-readable cataloging format or MARC-21. The scheme is reasonably usable, fairly refined, and it provides descriptive metadata for digital objects by regrouping the MARC fields, adding a few new ones, and translating the numeric codes to readable English in XML. MODS was adopted by the Digital Library Federation for their Aquifer project, which is seeking to develop the best methods possible and services for federated access to digital resources. DLF intends to use MODS to replace Dublin Core for descriptive metadata for digital objects in the digital library world, for MODS allows more specification of contents and better clarification of the various elements than Dublin Core. So far, we have discussed communication protocol and bibliographic standards. Now, let us discuss the standards that can be adapted for record structure. Record structure is defined as the physical and logical structure of the record which holds the data. A typical bibliographic record may contain multiple fields of variable length which may occur more than once, so they are repeatable. Except for proprietary structures, there is really only one structure used for bibliographic data of any complexity. These formats facilitate exchange of data between systems and are not intended for human consumption. Most digital library softwares support ISO 2709 for structure for individual records. ISO 2709 or Z39.2 defines a very flexible structure for individual records which were originally developed for tape storage. However, it is exceptionally well suited for handling the MARC format. The two standards were developed together, but 2709 can be the structure of almost any type of record. The main strength of 2709 is its ability to to handle variable length fields and records where the occurrence of fields is also variable. The encoding deals with the way individual characters are represented in the files and records. It is concerned with text within records almost exclusively. Most digital library software supports ASCII as well as Unicode to support multilingual requirements. Unicode is a universal encoding scheme using 16 bits to represent each character. It has the advantages of being simple, complete, and is being widely adopted. Its disadvantage is that all characters take twice as much space even for single language data. Unicode is controlled by the Unicode Consortium and is the operational equivalent of the ISO 10646 standard. ASCII, or the American Standard Code for Information Interchange, defines all the characters necessary for English and many special characters. This code has been used as the basis for most other 8-bit codes. The lower 128 are left alone. They contain the Latin alphabet, numbers, control codes, and some special characters. And the top 128 characters are used for a second language. IBM and Microsoft produced a number of national variants for the PC-DOS operating system, and these have a large measure of acceptance through wide distribution. However, they are only a manufacturer's standard. The Z39.50 is an ANSI NISO standard for information storage and retrieval. It is a protocol which specifies data structures and interchange rules that allow a client machine to search databases on a server machine and retrieve records that are identified as a result of such a search. Z39.50 protocol is used for searching and retrieving bibliographic records across more than one library system. Like most applications working under client service environment, Z39.50 needs a Z39.50 client program on one end and a Z39.50 server program on the other end. The Z39.50 standard has become widely accepted as a solution to the challenge of retrieving multimedia information, including text, images, and digitized documents. The Open Archives Initiative's Metadata Harvesting Protocol, or the OAI-PMH, defines protocols that support creation of interoperable digital libraries, allowing remote archives to access its metadata using an open standard. The OAI-PMH supports streaming of metadata from one repository to another, and its harvesting by a service provider. A service provider can harvest metadata from various digital repositories distributed across universities and institutions to provide services such as browsing, searching, alert, or annotation. In essence, the OAI-PMH works in a distributed mode with two classes of participants, that is, data providers, domain-specific digital repositories and institutional repositories, and service providers or specialized search engines. The figure on your screen shows graphical representation of OAI-PMH architecture, wherein the data providers are OAI-compliant institutional repositories or domain-specific digital repositories set up by the institutions and universities. IRs use OAI-compliant software that supports the OAI-PMH. The OAI-PMH protocol enables data providers, that is, repositories, to expose structured metadata of publications stored in repositories to the internet so that it can be harvested by service providers. Whereas the service providers or harvesters issue OAI-PMH requests to data providers, that is, OAI compliant digital repositories, in order to harvest metadata so as to provide value added services. The metadata stored in the data provider's database is transferred in bulk to the metadata database of the service providers. OpenURL is a versatile linking standard that uses metadata instead of an object identifier such as DOI for generating dynamic link by passing metadata about a resource to a resolver program. It consists of two components, that is, the URL of OpenURL resolver followed by a description of the information object consisting of a set of metadata elements. Example, author, journal issue number, volume, year, etc. OpenURL was originally developed by Herbert van de Sompel, a librarian at the University of Ghent. His link server software, SFX, was purchased by the library automation company Ex Libris, which popularized OpenURL in the information industry. The National Information Standards Organization, NISO, has developed OpenURL and its data container, the context object, as International ANSI Standard Z39.88. Let us try to understand the working of OpenURL by this graphical representation. For OpenURL to work, a library is required to set up a resolution server with information on full text journals accessible to the library with their link, as well as how to link to local print holdings and other local services. The information provider or publisher must also be OpenURL enabled to redirect the linking request to the local resolution server. A link resolver or link server parses the elements of OpenURL and provides links to appropriate services as identified by a library. OpenURL link allows access to multiple information services from multiple resources, including full text repositories, abstracting, indexing and citation databases, online library catalogs, document delivery service, and other web resources and services. When a user clicks on an OpenURL link, he or she is directed to OpenURL resolver. The resolver, based on the services availed by the library, provides him an HTML page consisting of a set's links to resources from where users can access the resource, like full text from publisher's site, DDS, aggregators, etc. The user selects an appropriate service, clicks on the link that takes him to the site of the service provider. For a digital library, formats and media types also play an important role. A defined arrangement for discrete sets of data that allow a computer and software to interpret the data is called a file format. Different file formats are used to store different media types like text, images, graphics, pictures, musical works, computer programs, databases, models and designs, video programs, and compound works combining many types of information. Every object in a digital library needs to have a name or identifier which distinctly identifies its type and format. This is achieved by assigning file extensions to the digital objects. The file extensions in a digital library typically denotes formats, protocols, and rights management that are appropriate for the type of material. Information contents of a digital library, depending on the media type it contains, may include a combination of structured and unstructured text, numerical data, scanned images, graphics, audio, and video recordings. Formats and encoding used for text. Text-based contents of a digital library can be stored and presented as simple text or ASCII, unstructured text, and structured text or SGML or HTML or XML. Simple text or ASCII is the most commonly used encoding scheme used for facilitating exchange of data from one software to another or from one platform to another. Simple text or ASCII is compact, economic to capture and store, searchable, interoperable, and malleable with other text-based services. The ASCII cannot be used for displaying complex tables or mathematical formulas, photographs, diagrams, graphics, special characters, and others which cannot be displayed in ASCII. The ASCII format does not store text formatting information, that is, italics, bold, font type, font size, or paragraph justification information. Hence, it is inadequate to represent many journal articles. Although simple text or ASCII is extremely useful for searching and selection, its inability to capture the richness of the original makes it an interim step to structured text formats. Structured text attempts to capture the essence of documents by marking up the text so that the original form could be recreated, or even to produce other forms such as ASCII. Structured text format has the provision to embed images, graphics, and other multimedia formats in the text format. SGML or Standard Generalized Markup Language is one of the most important and popular structured text format. SGML is an international standard, ISO 1986, around which several related standards are built, including HTML or Hypertext Markup Language, the de facto markup language of the World Wide Web. Extensible Markup Language or XML is derived from SGML to interchange structured documents on the web. Like SGML, XML also deals with the structure of document and not its formatting. The cascading style sheet or CSS developed for HTML would also function for XML to take care of formatting and appearance. Like simple text or ASCII, structured text can be searched or manipulated. It is highly flexible and suitable both for electronic and paper production. Besides SGML and HTML, there are other formats used in digital library implementation. TeX, used for formatting highly mathematical text, is one such format which allows greater control over the resulting display of document, including reviewing the formatting of errors. Page description language or PDL, such as Adobe's PostScript and PDF, are similar to image, but the formatted pages displayed to the user are text-based rather than image-based. PostScript and PDF formats can easily be captured during the typesetting process. The documents stored as PDF require Acrobat Reader at the user's end to read or print the document. Acrobat's portable document format or PDF is a byproduct of PostScript, Adobe's page description language that has become the standard way to describe pages electronically in the graphics world. While PostScript is a programming language, PDF is a page description format. The digitally scanned images are stored in a file as a bitmapped page image, irrespective of the fact that a scanned image contains a photograph, a line drawing, or text. An image file stores discrete sets of data and information allowing a computer system to display, interpret, and print the image in a predefined fashion. An image file format consists of three distinct components, that is, header, which stores information on file identifier and image specifications, image data consisting of lookup table and image raster, and lastly, footer that signals file termination information. While bitmapped portion of a raster image is standardized, it is the file header that differentiates one format from another. TIFF or tagged image file format is the most commonly used page image file format and is considered to be the de facto standard for bitonal images. Images can be colored, grayscale, or black and white, called bitonal. They can be uncompressed or raw, or compressed using several different compression algorithms. Image files are much larger than text files, thus, compression is necessary for their economic storage. Some of the formats mentioned above are maintained and developed by international organizations such as the International Standards Organization, the International Telecommunications Union, etc. Digital preservation is considered to be a very important factor of digital library. Let's have a look at some of the standards for digital preservation. The digital preservation metadata is a subset of metadata that describes attributes of digital resources essential for its long-term accessibilities. Preservation metadata provides structured ways to describe and record information needed to manage the preservation of digital resources. In contrast to descriptive metadata schemes, example MARC and Dublin Core, which are used in the discovery and identification of digital objects, preservation metadata is sometimes considered as a subset of administrative metadata design to assist in the management of technical metadata for assisting continuing access to the digital content. Preservation metadata is intended to store technical details on the format, structure, and use of the digital content, the history of all actions performed on the resource, including changes and decisions, the authenticity information such as technical features or custody history, and the responsibilities and rights information applicable to preservation actions. The scope and depth of the preservation metadata required for a given digital preservation activity will vary according to numerous factors, such as the intensity of preservation, the length of archival retention, or even the knowledge base of the intended user community. Premise or preservation metadata implementation and strategies. Composed of more than 30 international experts in preservation metadata, Premise sought to define a core set of implementable, broadly applicable preservation metadata systems supported by a data dictionary, and to identify and evaluate alternative strategies for encoding, storing, managing, and exchanging preservation metadata in digital archiving systems. The final report of the Premise Working Group was released in May 2005. The Premise Data Dictionary is a comprehensive practical resource for implementing preservation metadata in digital archiving systems. It defines implementable core preservation metadata along with guidelines and recommendations for management and use. Premise also developed a set of XML schema to support the use of the data dictionary by institutions managing and exchanging premise conformant preservation metadata. Open Archival Information System, or the OAIS, describes all the functions of a digital repository, that is, how digital objects can be prepared, submitted to an archive, stored for long periods, maintained, and retrieved as needed. It does not address specific technologies, archiving techniques, or types of content. The OAIS reference model was developed by the Consultative Committee for Space Data Systems (CCSDS) as a conceptual framework describing the environment, functional components, and information objects associated with the system responsible for the long-term preservation of digital materials. The metadata in OAIS model plays an important role in preserving digital content and supporting its use over the long term. The OAIS information model implicitly establishes the link between metadata and digital preservation, that is, preservation metadata. The OAIS reference model provides a high-level overview of the types of information needed to support digital preservation that can be broadly grouped under two major umbrella terms called as Preservation Description Information (PDI) and Representation and Descriptive Information. The module introduced standards and protocols, their roles and importance in building digital libraries. We have elaborated upon important digital library standards and protocols used for digital communication, that is TCP/IP, HTTP and FTP, bibliographic standards, that is MARC, Dublin Core, BIBI, TEI, EAD, METS and MODS, record structure, that is ISO 2709 and Z39.2, encoding standards like Unicode and ASCII, information retrieval standards, that is Z39.50, SRW and SRU, OAI-PMH and OpenURL, formats and meta types used in digital library and digital preservation, including unstructured text formats ASCII, structured text formats, that is SGML, XML, ODA, HTML and TEX, page description language, that is PDL, example PostScript and PDF, page image formats, example TIFF, image PDF, JPEG, etc., and preservation standards such as PREMIS and OAIS.